Hello, friends. This is Bhavdeep. Thank you for joining on time. Today we are going to study effects of current, mainly heating effects of current. But let's wait for 60 more seconds for more students to join in. I already see a big audience here. So another 60 seconds for students to join, and we are ahead of the schedule anyway. So we still have about a minute to start the class. So please stand by, take your seats, get a bottle of water if you have to, because it's going to be a lot of fun. I don't want you to miss any part of it, and please have a pen and paper ready with you. Everybody should have a pen and paper. Please grab it if you want to. If you don't have it right now, I mean, it's mandatory. You have to have a pencil or pen or some kind of writing device with you, please. 30 more seconds, and I already see a lot of audience here. Thank you, everybody, for joining on time. And this is going to be two varieties or two versions of webinar. A few of you are already live connected with me, where I can chat with you. You can respond with me. For other group who are not able to join live, they are watching. They will be watching on YouTube. So both the groups, I welcome both of you, both the groups here, and I can guarantee a lot of fun in class today. Another 15 seconds, we are going to get started. So stay tuned, please. Get a writing pad, get a pencil, pen, whatever, and a bottle of drinking water, or a hot cup of tea. I mean, whatever you like. So, guys, it's scheduled time, and let's get started today. So, first of all, few of you might have taken classes with me, webinars with me, or know about me. But for you, some of you, I'm pretty new. So, let me introduce myself. Who am I? So, I am Bhavdeep Singh. I live in the beautiful city of Chandigarh. Completed my master's in technology from IIT Bombay in 1998. So, most of the students here, I mean, assuming you are in 10th grade and were not even born there. Because I say most of you, because I have seen many of the parents also join. They want to learn something new, or they want to revise their physics concepts. They are also welcome. So after I completed my master's in technology, I started working in software industry. I worked there for a while, but then I realized I am actually a teacher. I should be teaching, and I love physics. I love kids. I love teaching physics to the kids. So I gave up my job initially part time, and then I started teaching few students, and then ultimately 5 years ago I gave up all my software profession, and I am a full time teacher now. All I do is teach with Vedantu for almost 3 years with Vedantu, and 2 to 3 years outside of Vedantu experience. So I have helped thousands of students here, and when I say students, they are students like ninth grade, 10th grade, 11th, 12th, or maybe there are variety of students I have helped with. Some of them wanted to clear JEE or NEET an exam, and then want to become doctors, engineers. But some of them come here just to learn physics. I mean, they have a passion for physics like me, and they take up research. Or maybe some parents come and they say, okay, sir, can you teach us few concepts? I love teaching anybody with any age group. So my mission in life is to make my student fall in love with physics. So that's the thing I'm working here for. So everybody should be loving physics, and you cannot enforce any kind of love. So the way I try to do that is I make my classes fun, so that once you take a few classes with me, you start loving physics. And I'm really sorry if some of the text is cut off there. I was focusing more on the slides for teaching the content for today. But my mission is to make my students fall in love with physics. And as I said, my students include all age groups. So आज का एजेंडा क्या एजेंडा है आज we there is a chapter in grade 10th which is called effects of current, right? So effects of current may include heating effects of current, magnetic effects of current, chemical effects of current. And since we have 1 hour here, we are going to focus mainly on heating effect of current. So we use that in toasters, iron, kettle, stove, water heaters, right, geysers. So wherever we convert electricity or the electrical energy into heat energy, that is aaj ka agenda. There are a couple of surprises coming up, so stay tuned for next 60 minutes. The biggest achievement would be you will be becoming an expert in heating effects of current. You do not need to study any further. You will be solving any kind of level of questions there, including some IIT level questions. When I say IIT, I mean the entrance exam for IIT. Fun is guaranteed here, so that is an extra bonus here. So stay tuned. So let's start with a puzzle. I usually start my class with a some riddle or puzzle. So you are locked inside a car with nothing but a baseball bat, maybe baseball bat or cricket bat, hockey or whatever. How do you get out? So students who are live with me, please reply on the chat box. I already see 10 students writing different kind of responses, and this is what I like about it. Students give out of the box responses, right? There is no right answer, there is no wrong answer. Okay, 25 responses so far, thank you so much. And most of you are saying, why don't you just unlock the car? That's right? So you're locked inside a car, not outside the car. So inside the car, you can just pull up the knob, get off, right? Yeah. But there are variety of answers here. A student says, "Sir, I'll just make a phone call to my friend and start chatting. Use the time." Somebody says, "Okay, I'll start watching a movie on my mobile." Somebody says, "I'll just relax." Everybody has out of the box answer here. Okay, so let's get started with what is current. So we are going to study heating effects of current. But before that, what is current? So anybody, please tell me on the chat box. Perfect. Yes. Students are very excited today for today's class. Thank you so much. I already see 30 responses there. So what is current? So let's take a wire here. I have a few props. So a wire here, and I connect some kind of bulb maybe on that. So I'm not going to do that, but then and I connect a battery. So basically, what is current? Current is this is an electric conductor, and you have already studied that. I'm just going to revise it in a few seconds. So charges are flowing in this, right? Free electrons flow inside the wire. So and then maybe I have some superpowers here. So let's say this was my wire. This is my wire, and then as I said, I have superpowers. So I sit here and I take a cross section. So everybody understands cross section, I'm assuming. So charges flow through that, right? Charges as in electrons flow through that. And then since I have superpowers, I can count the number of electrons that go through in a given time period. And then I know the charge on one electron. I can say the amount of charge that flows per unit time. एक second में कितना charge इधर से उधर गया. That is defined as the electric current, right? So everybody has studied this. I'm assuming charge per unit time. So basically that is coulombs per second, but that is also called ampere, right? So to honor Mr. Ampere. So let's quickly do a tiny little kind of question here just to revise or brush up the concepts we had already studied. So let's say there is a battery of 6 volts, and then this is, let's say, 2 ohms resistance, and V equals IR. I'm assuming everybody has mastered this, right? So voltage is 6 volts is equal to some unknown current multiplied by 2 ohms. So the current comes out to be 3 amperes. ठीक है. So अब क्या हो रहा है कि इसमें से current flow हो रहा है 3 amperes. What that means? What does that mean? That means that in 1 second, 1 coulomb of charge is flowing from here to here. And then everybody knows, I'm sure, that the current actually flows from positive to negative, but in reality, electrons flow this way. But I'm going to talk of conventional current throughout the class today. So as far as conventional current goes, there is a positive charge that is flowing in this direction. Okay. And 1 coulomb of charge is flowing every second. That is what this means. Clear with that? Anybody has any confusions, any doubts? Please let me know. So with that background of current, let's go and see what is heating effect of current. So अब ये जो wire थी मेरी, this wire, I had some electrons flowing through that, right? So electrons are flowing fine, but it's not a smooth journey. ऐसा नहीं है कि let me draw another slide here. This is a wire maybe. It's not like electron is sitting here at point A and point B is the goal, so it'll go zoom. It's not a free kind of track over there. It's not like your Asian Games going on right now, track and field events over there. So this is not a race track that you're free. Nobody is on your way. In reality, what would happen is there are ions, right? This wire is made up of copper. So there are ions there. There are impurities there. So as this poor electron is trying to go from A to B, look what happens. It actually would try to go there, but then it collides. collides मतलब टक्कर हो गई उसकी, ठीक है. So when it collides, it's kind of like two rubber balls colliding. This will collide with an atom and then change its path and lose some of the energy there. Think about a ball going with a very fast speed colliding with another ball. The fast speed ball loses some energy, some momentum to the slow kind of ball there. And then again it goes and collides with something else, and then collides again, collides again, collides again. I mean, it keeps on doing that, and eventually this poor electron reaches the other end. So this is what is being illustrated where here. Right? So electron is trying, but then it on the way it collides with some ions. अब क्या होगा उससे? That is the key to heating effect. So please focus more on this slide. This is the key to the heating effect of current. तो फिर से देखते हैं एक बार, फिर एक clean बना लेते हैं. So यहाँ पे है ये वायर थी. There is an ion here, the atom, right? So everybody knows the atoms of a solid, they vibrate. ठीक है? वो they're not stationary, they keep vibrating. So let's say this atom was vibrating here in some random direction. ठीक है? दूसरा atom था यहाँ पे. We'll draw a few of them only. This was vibrating like this, and there was a third one here. It was vibrating maybe some other direction, maybe this way. Okay, there are some atoms that are vibrating already, and please keep a note of this if you do not know. This vibration is the when you say the temperature of something, let's say temperature is a measure of these vibrations. So जब हम कहते हैं ना कि this body is 20 degrees Celsius and this is 40 degrees Celsius, what we mean by that 40 degrees Celsius is the atoms are vibrating more in that. So that 40 degree, as you will study in grade 11th, is a measure of, so when you come to grade 11, you will actually be, if I tell you the temperature of this is 40 degrees Celsius, you will tell me, oh sir, every atom is actually vibrating with this much of kinetic energy. We'll go to that level next year. But for now, make sure you understand temperature is a measure of vibrations. What that means is, more the vibrations, more the temperature of the body. Less the vibrations, less the temperature of the body. So अब देखते हैं इलेक्ट्रॉन ने क्या किया. And these are the things, they are not in your book, so that is why I'm asking you to pay extra attention. Most of the 10th grade books will not talk about this. So एक poor atom है, electron है, sorry. This electron wants to go from point A to point B. What happens now? It tries to do that, but then boom, collides. कोलिजन हुआ तो उससे क्या हो गया, उससे बहुत कुछ हो गया. उससे जो एटम था, it was vibrating, but now it's vibrating more because it has more energy now. Electron gave some of its energy. अब this electron, poor electron, loses some energy and then collides with another atom, loses more energy, and this one starts vibrating more. This starts vibrating more. So as electron is going from here to here, and eventually it reaches there, obviously it reaches there and completes the circuit. But in the process of motion, what it has done is it has given some of its energy, which was actually electrical energy, to the atoms here. ठीक है? When it gives the energy to the atoms, atoms start vibrating more. But look at it, more vibration more means more temperature. The slow motion में एक बार देख लेते हैं last time. What happened just now is this. So there is a wire here. There is a wire. And let's say there is a battery here. Let's put negative here, positive here. So then electron flows from negative terminal to the positive terminal. ठीक है? So now there is an electron here. And because of the potential difference, electrons flow from negative to positive, right? Conventional current is shown going the other way, but in reality, electrons flow negative to positive. So while the electrons are flowing, what they are doing is they are giving some of the energy to this wire, and this wire's atom are vibrating more and more. But if they are vibrating faster and faster, the temperature increases. So इस process में क्या हुआ कि the electrical energy is converted into heat energy or the thermal energy. This is a brief introduction to what happens behind the scenes. ठीक है? I would advise everybody to rewind the video who is watching on YouTube and go through the past 5 minutes, because that is the background of what happens here. ठीक है? अब देखते हैं क्या होता है. ठीक है, मैथमेटिकली क्या होता है. लेट्स एनालाइज मैथमेटिकली. एंड बाय द वे दीज नॉट एवरी वायर इज मेड इक्वल. सो इफ आई टेक दिस वायर विच इज मेड अप ऑफ, आई थिंक कॉपर वायर, हाँ ये कॉपर वायर है. सो इफ द इलेक्ट्रॉन्स फ्लो थ्रू दिस, नॉट मच ऑफ रेजिस्टेंस इज ऑफर्ड बाय दोज एटम्स इनसाइड ऑफ इट. So then a little part of the energy is converted into heat, and that is good because the purpose of this wire is just to conduct electricity and make my music player work, maybe, right? But then what do you want to do inside a geyser, inside iron, right? You want to actually convert electrical energy into heat energy, and that is why you specifically use resistor. So if this is a resistor wire, it is going to convert electrical energy into heat energy. Now these are conducting wires. Right. So if you look at the iron there, so we are on slide 10, we'll go back a little. ये iron जो थी इसमें एक wire थी, right? This wire was a conducting wire, and inside of this wire there is a resisting wire. So that resisting wire actually is converting electrical energy into heat energy. अब इसको mathematically देखते हैं, mathematics में. Now go back to mechanics. क्या पढ़ा था हमने? Power is work done per unit time पढ़ा था ये, work done per unit time, ठीक है? And then in the previous chapter you have also studied what is potential. Potential is the work done per unit charge. When 1 coulombs of charge flows, how much is the work done or energy released? ठीक है? So what we say is, let's say this is our circuit, and I'm trying to cover everything that you might have already covered, but this is the thing that you actually need to know. So 2 ohms, or ये आ गया 3 amperes. Now when we are saying 6 volts actually means when 1 coulombs of charge goes through the circuit, energy released is 6 joules. So 6 joules per coulomb. So volts का मतलब क्या है? This is same as saying 6 joules per coulomb. ठीक है ना? So with that you get, okay, the work done actually is volts times coulomb. So I can take this thingy and plug it in here. तो मेरे पास क्या आ गया? Power is equal to voltage times charge divided by time. ठीक है? Simple. अब charge divided by time क्या होता है? Can anybody tell me please? Charge over time. Thank you so much. Yeah. 40 responses here, I guess. Yeah, I mean, I've not counted it, but I can see them. It's zoom. Chat box is full. Everybody is saying one and the same thing. This is current. So then I can say power is equal to voltage multiplied by current. ठीक है? अब हमने कहाँ से शुरू किया था? हमने मैकेनिक्स की कोई डेफिनेशन से शुरू किया था कि पावर इज वर्क बाय टाइम, एंड देन वी सेड वर्क इज एक्चुअली वोल्टेज मल्टीप्लाइड बाय चार्ज, बिकॉज वी आर डीलिंग विद इलेक्ट्रिक चार्जेस हियर. वी आर नॉट डीलिंग विद मी पुशिंग द टेबल, वी आर डीलिंग विद इलेक्ट्रिक चार्जेस हियर. तो इलेक्ट्रिक चार्ज के कॉन्टेक्स्ट में वोल्टेज टाइम्स चार्ज is giving you the work done. So then I plug that in here. I get power is, so let's do one more time. For some students are saying ek bar aur sir, please one more time. That's fine. This is the thing, right? Now instead of work you can write voltage times charge divided by time, but charge divided by time is the current, so voltage times current. So power कितनी हो गई? अब एक बार यहाँ पे देख लो, फिर से सर्किट बना दिया. Same circuit, nothing new here. I'll use the same numbers here so that you don't focus on calculations there. You focus more on the concept here. ये आ गया मेरे पास. ठीक है? Everybody understands this. V is equal to IR. But every time, this is a resisting wire. So what is happening now? Every time the charges are flowing through this, some energy is converted into heat energy. So how much energy is converted into heat energy? The energy converted every second is 6 volts multiplied by 3, which is 18 joules per second, which is also called 18 watts. Joules per second is watts. So in the given circuit, the amount of energy released, or the power of the bulb there, or whatever that element is 18 watts. It is converting 18 joules of electrical energy into thermal energy every 1 second. 1 second में. ठीक है? Now you might want to rewind the video or maybe see that later on one more time. Let's do a quick numerical here. So let's say there is 15 volts here, 3 ohms here. Now calculate the power. Everybody, please do it. Pause the video if you're on YouTube. For the live students, I'm giving you 30 seconds. It's not more than 30 seconds. Awesome job. So many students might have done this, obviously. You calculated current is equal to voltage by ohms, which is 5 amperes of current. ठीक है? And then you say, oh, power is equal to voltage multiplied by the current. ठीक है, 75 वॉट्स ये हो गया। ठीक है, एक बार और एनालाइज कर लो यहाँ पे इसको। पावर क्या है? पावर इज वोल्टेज इनटू करंट, ये तो हमने कर लिया अभी, बट वी ऑल्सो नो V इज इक्वल टू आई आर। वी नो V इज इक्वल टू आई आर, तो ये V की जगह यू कैन प्लग इन आई आर, तो पावर कितनी हो गई? आई स्क्वायर आर। ठीक है ना, उसकी जगह वो रख दो। सिमिलरली करंट कितना? V बाय आर, तो करंट I की जगह V बाय आर रख दो, तो ये कितना बन गया? V स्क्वायर बाय आर। तो ये तीन एक्सप्रेशन हो गए विच आर सेम बिहाइंड द सीन्स, दे आर ऑल सेम। सो यू कैन यूज P इज इक्वल टू VI, you can use P is equal to I square R, or you can use P is equal to V square by any of them, whatever you like. Why would you like to use one or the other? Because see, in this given scenario, मेरे को ये पता था, I knew this information, so I don't have to see, I have to find the power, right? So why do I find the current? I don't have to. I will say I have to find the power. I have three options. Let me write down all the three options here. ठीक है, I have three options. अब मेरे को क्या इंफॉर्मेशन है? I know the voltage, I know the resistance, so I'm going to hunt for a formula here which is going to use voltage and resistor. So मेरे को ये पता है, ये यूज कर सकता हूँ. So you can do that. Power is equal to V square by R. And that also will give you the same result, 75 watts. ठीक है, you can do whatever way you like. I'm just giving you options here. In physics, you have multiple ways to deal with the same situation. So, and that is why the physics is so beautiful, because you're given a situation, you can deal with it with some work energy theorem. Maybe you can deal with it with the kinematics equation. You have n number of ways to deal with that, and every method is all right, perfect. It's your choice. You are given the power. ठीक है, ये वाली power नहीं, power to choose, डेमोक्रेसी वाली पावर। ठीक है, सो यहां तक समझ में आ गया एवरीबॉडी? अभी मैं क्वेश्चंस कराऊंगा, आई विल गिव यू क्वेश्चंस टू डू, सो स्टे ट्यून्ड हियर, यू विल डू द क्वेश्चंस। तो we'll make one more circuit here, and then you will start doing questions. I'm going to give you situations and you analyze that. क्या लिख दूं यहाँ पे? Maybe I'll write, I don't know, 20 ohms, some numbers, I'm randomly writing it. 4 ohms. देखो भाई ohms में कैसे आ जाएगा, तो बैटरी है 20 volts and 40 ohms. ठीक है, now let me write the question. Find heat generated in 1 minute. एक मिनट में कितनी हीट जनरेट हो रही है? You know there is energy converted from electrical to heat energy. In 1 minute कितनी हो रही है? That's a question. In 1 minute. ठीक है, so take your time, maybe 60 seconds here, or maybe a little less. Very easy, very easy, very easy. भाई तुमने तो फटाफट कर दिया. Somebody already gave the answer, and I can guarantee every student will be able to do that. Based on, if you have seen the past slides, this one is a piece of cake for you. If you have followed the past slides. Good job, awesome there. So let's try to do this. What is the data given to me? I am given that resistance is 4 ohms. ठीक है, what else is given? Voltage is given as 20 volts. ठीक है, what do I have to find? I have to find the heat. Find. ठीक है, ऐसे लिख लो, like short में कि भाई क्या, what is the goal? Goal is to find heat. Now we don't know any formula for heat as of now. We have not done that, but we know the formula for power. Power is heat per unit time, isn't it? So heat से शुरू करते हैं. Heat is equal to power into time, है ना? That's what we will do. अब पावर का मुझे पता है कि there are 3 formula. Which one should I use? I keep writing them. So until you get comfortable with doing it mentally, you should be actually writing all the 3 choices. उससे क्या होगा? Revision भी हो जाएगा. अब इसमें V और R पता है मेरे को, तो ठीक है, let's pick this one. So then you can say V square by R multiplied by time. And I do see a few students making one simple mistake. Yet they are not converting time of 1 minute into seconds. You got to deal with in SI units. तो voltage कितना है? 20 squared, right? 20 by 20 divided by resistance is 4 multiplied by 60. ये करना है आपको, ठीक है? Because this is joules per second and times seconds. That will give you joules. So यहाँ से ये क्रॉस कर दो, 15 से कट गया, तो 400 में 15 6000 joules. Anybody who did not understand, please ask me. Anybody who did not understand. ठीक है. Now unit wise, let's analyze some units here. So हमने क्या लिखा? Heat is equal to power multiplied by time. ठीक है. This is a mistake that many of the students made. That's why I'm covering this again. Power is measured in watts. Watts is joules per second. अब अगर टाइम मिनट्स में लिखोगे तो गड़बड़ होगी ना. इट्स नॉट क्रॉसिंग दिस आउट. सो दैट इज व्हाई यू गॉट टू राइट दिस इन सेकंड्स. यू हैव टू कन्वर्ट 1 minute into seconds. Seconds will cross out and joules will remain. And that's a really good idea to match the units. So let's start doing some questions. You are going to do those. Practice makes perfect. So please try this. Good. 3 answers already in. I was expecting more, by the way. So please. Yeah. Yes. One answer is wrong. You're using the wrong formula. I can see that. Somebody is using V square R. Please see the formula. List down all the 3 formulae that we have and then choose the correct one. You're using V square multiplied by R. I can see that. ठीक है. The student has corrected that. Good. Awesome job. Big response here. Awesome there. Okay. So find the energy used per second. Energy used per second is same as power, right? Energy per second. तो power का formula use कर लेंगे. Power is either VI, I square R. You really have to write it down every time for next few days at least. And then you will not have to. इसमें क्या क्या पता है हमको? We know the resistance. And we know the voltage. तो फिर वही same formula बार बार use हो रहा है. That's fine. We'll use other formula also. So this is V square, which is 100 times 100 divided by 5. So that crosses out as 20 here. So 2000 watts. ठीक है? Let's try the next question. Good. It's already responses, 11 responses so far. I'm just counting the roughly 11 or maybe 13. Okay, 2 more responses came in. Good. Awesome. And there are surprises coming up in the class and stay tuned for that. And you're going to do difficult questions also. These are really tiny questions for you. I'll make you do difficult questions. 10th grade is going to be piece of cake because I'm going to prepare you for JEE. In today's class, you'll do few questions. Okay. तो अब इसमें क्या पता है? Just write down whatever you know. Heat produced per second, heat per time is given as 100 joules per second. है ना? ये दिया है हमको. This is the tiny little trick there, and it's not really difficult. They're saying 100 joules of heat is produced every second. Joules per second is actually watts. So, आपको actually power दिया है. We are given power. We are not given the heat. We are given power here. Joules of heat per second is same as power. ठीक है? So, हमको दिया हुआ है 100 watts of power. This was a little twist in the question. That's all. 100 joules of heat is produced every second. It's same as saying 100 watts. Please, everybody focus here. I'm going to come back to this slide. So power is work. Or work is same as energy, right? No difference. Same as heat. That doesn't matter. It's all same, right? They're all measured in joules per unit time. अब units पे ध्यान दो. The units for work, energy or heat is joules. है ना? Time की है seconds. SI units only, please. No other units. And this is watts. So watts is same as joules per second. So if you're given joules per second, you are actually given the power, watts. Because I see 3 students ask me, sir, time nahi diya, heat diya, time nahi diya. Because see, what are the formulae? I'm going to revise it one more time for everybody. Power is equal to VI, I square R, V square by R, right? But then you can say heat is power into time. So you can write heat as VIT, I square RT V square by R times of T. So somebody was asking me, sir, time नहीं दिया, heat पर दिया है, तो time नहीं दिया because time per unit time ही दिया है ना वो, that's why, ठीक है. So power पता है हमको. Now we also know the resistance is 4 ohms. ठीक है, find the potential difference. So वही वही पुराना फॉर्मूला बार बार लग रहा है. So power is equal to V square by R. Power is 100 watts is equal to V square हमको नहीं पता divided by R. तो 4 दिया है तो इसको वहां मल्टीप्लाई कर दो. तो V square is 400. अब उसका स्क्वायर रूट ले लो. दैट कम्स आउट टू बी 20 volts. ठीक है, समझ में आ गया? एवरीबडी गेट्स इट? ओके. Try the next question now. Practice makes perfect. So you practice. I already have practice. It's your turn now. No calculators. One of the students is saying, sir, can I use calculator? No calculators allowed in CBSE exams. So no calculators, please. And thanks for your honesty, by the way. Yeah, you asked me, right? So yeah, thank you for that. Good. So many responses already. Yes, thank you for that. Okay, so let's list down. It's always a good idea to list down things. What are we given? We are given the voltage of 220 volts. Okay, we are given the current. Current is 0.5 volts. Okay, we are supposed to find the power. Supposed to find power. ठीक है, तो अब फिर लिख लो, फटाफट से लिख लिया करो कि what are the 3 options you have. Oh, it looks like I have to use the first one now, right? So power is voltage times current. This is what I'm going to use this time. So 220 volts multiplied by the current, which is 0.5, which gives you 110 watts of power. ठीक है, clear है? Everybody clear? Okay. So there are 3 students who are saying, sir, list down the formula every time is kind of boring. It's boring, right? I'm just saying until you have this in your on your fingertips, maybe you keep writing. You don't have to write, but so because see, I saw a couple of students, they were using V square R. That is why I'm saying. So these have to be on your fingertips. Once you have them, you don't write it. Right? So let's move on. I forgot to write the options here. Just give me the answers, please. On the chat box, yeah. Take your time. That's fine. It's easy. It's easy. Thank you. Yeah, that's fine. That's perfect answer there. Everybody has given the right answer here. Whoever has written, I cannot take individual names because there are so many students. I mean, everybody is doing the right thing. So that's why I cannot take the names, but I can see so many responses already coming in. So what is the operating resistance? We have to find this. Okay. Power is given as 100 watts. Okay. Operating line voltage is given to me as 120 volts. Oh, तो अब तो रट गया सबको कि कौन सा यूज करना है. So V square by R. Just plug in the value, and I think I'll increase the difficulty level after this because I can see everybody is doing the answers correctly. They're giving the right answers. So I have to challenge you more. The more I challenge you, the more you are going to learn today. You are going to go back and going to be masters in at least heating effects of current. Almost, right? So this is going to be 144 ohms. ठीक है, everybody gets it. So let me make up a question here. ये आ गया मेरे पास. ठीक है, और इसकी जगह ये पैरेलल में भी कर देते हैं. और इसको ऐसे करते हैं. नंबर्स थोड़े इजी ले लेते हैं सो दैट यू डोंट स्पेंड टाइम कैलकुलेटिंग एटलीस्ट. ठीक है, इसको 3 कर देते हैं तो इजी हो जाएगा. एंड मोस्ट ऑफ द स्टूडेंट्स नो व्हाई आई एम डूइंग दैट बिकॉज दैट्स वेरी इजी नो. ठीक है, तो अभी हो गया, इसको कर दो 18 वोल्ट्स. ठीक है, let's try to analyze this circuit now. This is something you have already done in the previous chapter. Now we are studying from perspective of power here. यहाँ पे क्या है, or maybe I'll just not break the circuit, then not put any meter. Find power here. How much is the power dissipated in 6 ohms resistor? So just the 6 ohms, and also find the total power maybe. Find the total power and also find the power dissipated in 6 ohms resistor. So please take your time. देखो तीनों resistors they're converting into the electrical energy into heat energy. So I'm interested in how much is being done here and how much is being done in total. Simple questions हो गया, थोड़ा मुश्किल question करना है. So students who are on YouTube, you can pause the video. ठीक है, 3 आंसर आए, उनमें से एक सही है and 2 are wrong, and I can see what mistake you're making. Try again. Take your time. That's fine. Try again. ठीक है, 8 responses so far. 3 are wrong, 5 are right. Absolutely. And I'm assuming you're giving me the power of 6 ohms so far. Okay. Now let's slow down here. I'm going to analyze this circuit very slowly, because maybe in the previous chapter you were not able to follow up how to analyze a circuit like this. You're going to learn it now. So please, everybody slow down here. Put your pencils away. Look at the screen here. You're going to learn heating effects, and also you're going to learn the previous portion where you were analyzing the circuits. अब इसमें क्या है, बैटरी looks at the whole thing as one thing, right? Battery doesn't care you have 6, 3 and 4 ohms. Battery says the whole of this has to be serviced by me. ठीक है, तो बैटरी को तो सप्लाई करना है करंट सबके लिए, है ना? तो बैटरी क्या करेगी, it will see okay total resistance here. So 6 ohms and 3 ohms they are in parallel. तो इधर क्या हो जाएगा, total resistance ऐसे कैलकुलेट करते हैं, 6 times 3 over 6 plus 3. This is how you calculate. See, basically I'm doing 1 by R is equal to 1 by R1 plus 1 by R2. ठीक है ना? जब इसका LCM लोगे तो what would you get? You will get R1 plus R2 over R1 R2. है ना? तो resistance कितना आ जाता है R1 R2 divided by R1 plus R2. So that is exactly what I'm doing. I'm multiplying them and dividing by the sum of that. तो ये आ गया मेरा 2 ohms. तो ये मेरा बन गया 2 ohms. जो पैरेलल का सर्किट है दैट बिकम्स 2 ohms. ठीक है, अब उस 2 ohms में दिस 4 ohms इज कनेक्टेड इन सीरीज. सो 2 ohms प्लस 4 ohms गिव्स मी 6 ohms. आ गया 6 ohms आ गया. ठीक है, नाउ 6 ohms आ गया, देन द बैटरी सेज आई हैव टू प्रोवाइड द करंट टू द एंटायर 6 ohms. तो कितना हो जाएगा, वोल्टेज डिवाइडेड बाय द एंटायर रेजिस्टेंस व्हिच इज डिवाइडेड बाय 6. सो 3 amperes of current. So the battery says, I'm going to give you 3 amperes of current. Now you deal with it. You divide among yourself, right? So 3 amperes of current reaches here. Like it's more like the cars coming here, and then the cars say, okay, and this is the analogy. I really like this analogy. Let's say there are cars coming on a highway. Okay. Now there are 2 choices they have to make, and ultimately they will go back and meet at the same place. अब सपोज मैं इसी का सेम बना लेता हूं. देयर आर 6 potholes here and there are 3 potholes here. ठीक है, गड्ढा potholes is गड्ढा, 3 गड्ढा here, 6 गड्ढा there. तो wouldn't you think that more of the cars will go through the lower branch here? More of the cars will go here, right? Not all the cars, because if all the cars go here, then there will be so much of traffic that it will be a traffic jam. So some cars will say, okay, even if there are more gaddas there, let me go through that path, right? So I can claim that less cars will come here and more cars will come here. That's guaranteed, right? But how much less, how much more? By statistics, I know will be twice. This is the twice of this. Does everybody agree to that? By statistics, because there are half number of gaddas there, so twice the number of cars will come here. So take an example. Let's say 9 cars come here I can claim that 6 will come here and 3 will come here. Happy, right? So let's say 15 cars come here, 10 will come here, 5 will come here. ऐसे divide हो जाएगी ना 2:1 के ratio में. So same thing applies here. 3 amperes of current comes here. So 1 ampere goes here and 2 ampere comes here. Double the current, double of that thingy. So उसको 1/3, 3 parts में करो divide. 2 parts go here, 1 part go there. And then ultimately both these currents will combine together and this becomes 3 amperes and 3 ampere returns back to the battery, which has to be true. यहाँ तक समझ में आ गया? ठीक है. Now let's focus on the power consumed in this here. इसमें हमको current पता है, हमको resistance पता है. ठीक है. So then what I can say is the power consumed here, let me make an arrow here, power is equal to I square R. I square R कितना हो गया? I square R हो गया 1 square multiplied by resistance which is 6 watts. पूरा भी कर लेंगे हम, पूरा सर्किट कर लेते हैं चलो. ठीक है. Power consumed here. Power consumed here is 2 square times 3 that is 12 watts. Clear है यहाँ? Everybody clear? है ना यार? अब यहाँ पे क्या हो जाएगा? Power consumed here is going to be 3 square times 4. 9 times 4, right? 36 watts. अब total power लिख लेते हैं. यहाँ पे कितना हो गया? Total आ गया मेरा. Total आ गया 36 हो गया यहाँ से, 6 हो गया यहाँ से, 12 हो गया यहाँ से. तो 6 and 6 12 and 2 is 4. 1 carry 54 watts आ गया. Everybody gets it? 54 watts is the total power. अब चेक कर लेते हैं भाई, भवदीप सर हैं, कोई सुपर ह्यूमन तो है नहीं, हो सकता है मिस्टेक करी हो, right? So maybe I made some calculation mistake. So you should always cross check things. So what I did just now is I found the power here, power here, power here. I added them up. But then what about I say okay, the total resistance of the circuit was 6 ohms and the total voltage of the circuit was 18 ohms. So the total power has to be V square by R. So V कितना है मेरा? 18 into 18 divided by R. R is 6. So cross 3, which is 18 times 3 is 54 watts. Either way you do that, you are going to get the same answers. ठीक है? चलो आगे चलते हैं थोड़ा सा. We will take a break of 2 minutes in the sense that I'm going to talk about something here. We are not done with the class. I'm going to give you difficult level questions. And there's another concept that I will cover after this. So just stay for 2 minutes. I'm going to talk about a new course coming up at Vedantu. You do not have to join it. I'm just telling you, if you want to study further on effects of current, this is for your good, right? So we are not done with the class. We are going to continue with more questions. So there is a new course that is coming up here, which is starting on Teachers' Day actually, coincidentally, 5th of September. This is a 13-hour class and we are going to cover heating effects of current and magnetic effects of current. ठीक है, both of them. So heating effect थोड़ा सा आज कर रहे हैं, but there are few things like kilowatt hours and all that. We will not be able to do that because I'm looking at the watch. I'll extend the webinar by a few minutes, but there is a limitation I can do. But we still have to cover a few more things on heating effect. Now magnetic effect is a big chapter itself. It needs a lot of time to explain. Right? So we are going to cover those two concepts in 13 hours. So we meet every Wednesday, 7 to 8 p.m. every Wednesday. Okay, for next 13 weeks, starting on 5th of September. So it ends on 28th of November, right before your exams. Now, I will be there. So I am the one taking this course. So obviously, Vedantu has a list of teachers who are called master teachers, and they take the batches. And I'm one of those teachers, and this batch is being taken by me. So if you like the class here, you might want to join the course. There is no obligation. But if you join the class, you are going to get more of understanding of the heating effect, plus you get to know the magnetic effects. Plus, I promised you a surprise. Here is a surprise for you. So the regular price of this 13-hour course is 2,600 rupees. But for the students who are taking this webinar today, there is a lightning deal going on for 999. So 1,000 रुपए में, right? for next 4 hours. This deal is valid for next 4 hours, not from now. When the webinar ends, you have 4 more hours from then to talk to your parents or and decide if you want to go for that. Here is the URL. Please note it down, and it is case sensitive. So all lowercase letters. Vedantu ka aa gaya ye. VDNT, right? All the consonants of Vedantu. Dot in and then B current. B stands for Bhavdeep, right? Bhavdeep current. Bhavdeep ka batch aa gaya current पे. Okay. So this is your surprise number one. The course is usually 2,600 rupees. Today, just for today, for the people, for the students attending this webinar, there's a lightning deal going on. So next 4 hours. So that's a surprise, right? Now, why would you want? So I've already received a few of the comments here. Sir, जब आप पढ़ा ही रहे हो, तो why should we join the course when you're already teaching heating effects of current? So why do we join it? So number one reason I already gave you. We are covering some of it in 1 hour, but the topics of heating and magnetic effects are so vast that we need 13 hours for that. So to get more insight into that. In addition, so these topics, these classes are taken by master teacher, right? Master effects of current with a master teacher, and that teacher is me, right? For this batch, it is me. I'm the one. I'm taking all the 13 hours, all 13 hours, right? 13 hours of live teaching, lots of questions and numericals in class. Today I've chosen 7 numericals because we have to cover the concept also. You get lot of numericals in the class, and after the class ends, you get assignments and there are unit tests on that. So assignment has a lot of questions. Plus, you become part of an exclusive WhatsApp group. Who are in the group? All the students of this batch, who are joining it. Plus, I am there. Plus, there are experts. Because see, if let's say you have a doubt in physics, and that physics doubt may not be effect of current, that may be mechanics, maybe, right? So you have a doubt in mechanics. So you can also ask that. What would happen is your fellow classmates are going to jump in and help you. I am going to help you. There are other physics experts who are going to help you. That is a 24/7 guidance available. But don't expect, okay, sir, 1 बजे मैंने question भेजा था, 1 बज के 5 मिनट हो गया, 5 मिनट हो गया, आंसर नहीं आया. ऐसा नहीं होगा. But you will get responses very fast. Maybe in an hour or couple of hours, you will get responses guaranteed there. Okay? So you become part of that exclusive group. Plus, you can replay the class anytime. So let's say you are not able to attend a class. Maybe you're stuck up in traffic. There's no power. There's some kind of emergency which I don't want to have. But let's say for whatever reason you're not able to join the class, you can revise the class by or replay the class. It's all recorded. Secondly, let's say you already joined the class and it's your exam time. You want to revise it. You can revise it anytime. You can replay the class. Okay. So that said, let's go to further topics. So here is the URL one more time. I'll show the URL before the class ends also. So stay tuned for that. Now, another concept is resistance does not change when you change the circuit configuration. इसका क्या मतलब है? This will be really useful when you do JEE Mains level questions. क्योंकि उसमें इतने simple question नहीं आएंगे कि resistance है, voltage दे दिया, find the power. You will not get those kind of questions. This is one of the concept that you really have to understand. Resistance does not change when you change the circuit configuration. ठीक है, समझ लेते हैं क्या मतलब क्या हुआ. Let's analyze that. So resistance does not change when you change the circuit. So what that means is, let's say you have a resistance here of 2 ohms. ठीक है. Now I connect it to a voltage of 6 volts. ठीक है, power ये आ गई तो current आ गया 3 amperes. Things again so easy to, right? So power कितनी होगा? You can use any of the formula, doesn't matter. Let's use V square by R or V times I, doesn't really matter. So V square by R कर लेते हैं because I want to show you with resistance there for some reason, right? 6 is square by 2 which is 18 watts. समझ में आ गया सबको? ठीक है. अब मैंने क्या करा, मैंने ये वाला जो रेजिस्टेंस है, टेक द सेम रेजिस्टेंस एंड चेंज द सर्किट कॉन्फ़िगरेशन एज इन प्लग इनटू अ डिफरेंट बैटरी नाउ. Everything will change. Literally everything will change. Let's say this is 12 volts battery now. Everything will change. What will not change is the resistance of the thing. Because if you have done this properly in your previous chapter, if not then I'm revising it anyways, the resistance of the wire depends on rho L and A. Rho is what material this is made up of. Length मतलब कितनी length है. Area is the area of this cross section. So when I take this resistance and plug it into another thing, none of the three things have changed. ये जिस भी material का था same material है, length भी same है, area भी same है. So resistance will not change. So then I can directly write it as 2 ohms here. What changes now is the current. So current हो गया 6 amperes. And the power becomes 72 watts. Power बन गई 4 times now. Right? So you can do V square by R or IA, whatever. So you can see everything will change, but the current resistance will not change. And you can use it for shortcuts actually. So let me show you how you are going to do. So, okay, students are saying, show it one more time. So this is the concept I was saying. Resistance उठा के यहाँ लगा दिया. It is not going to change the resistance. It is going to change the current, voltage change, current change, power change, heat generation change. Resistance will not change. ये concept very handy होगा when you can do the questions in maybe 5 to 10 seconds compared to taking a lot of time. So this is the example I gave you. You might want to pause the video or rewind it and see that. Let's do a question here. Let's see. Okay. So everybody try to do this for next 30 seconds and then I'm going to explain that. Don't look at what I'm doing. Just focus on what you were doing. I'm just trying to save your time here. I'm going to give you a shortcut as to how you can do it in 5 to 10 seconds here. Okay, I already see 5 responses here. Thank you so much. Yeah, 5 responses. All 5 are right actually. So I don't know what method you used, the long method or the short method. Your responses are right. 7 responses are right out of 9 responses I got so far. Awesome job, guys. Awesome job. Okay, so let's see the short method here. Let's see the long method and the short method. ठीक है, long method क्या है? Remember the resistance does not change. So ये हमको दिया है कि this bulb was rated 8 watts when you plug it into 40 volts. This was the recommendation given by the manufacturer of the bulb. He said do this and you will get 80 joules of energy every second. You said, no, I don't want to do that. I'll not follow your recommendation. Remember democracy. You have the choice to do that. So what you do is you take that bulb and you plug it into 10 volts. The manufacturer said, do this and you get 80 joules. But you said, no, I only have 10 volts. I'll do that. So how many joules you will get every second? That is the question. तो अब इसमें देखो तुम पावर दिया है वोल्टेज दिया है ठीक है तो आई कैन ऑलवेज डू दैट आई कैन से ओके लॉन्ग मेथड फर्स्ट लॉन्ग मेथड दिस इज रियली लॉन्ग मेथड सो आई कैन से पावर इज इक्वल टू वी स्क्वायर बाय आर ठीक है और R इज इक्वल टू वी स्क्वायर बाय पी सो आई कैन कैलकुलेट द रेजिस्टेंस हियर आई कैन से 80 times 80 divided by 40. I don't have to do the calculation. I'll directly plug in the value. ये मेरा resistance आ गया. But let's calculate anyways. ठीक है. V square by power, right? Power was 40. Oh, sorry. So V square by P, right? So उल्टा कर दिया. So V कितना है मेरा 40 times 40. ठीक है डिवाइडेड बाय 80 वॉट्स तो 80 यहाँ रख दिया इसको क्रॉस कर 2 कर दिया सो 20 ओम्स का रेजिस्टेंस है वो डज एवरीबॉडी अंडरस्टैंड 20 ओम्स का रेजिस्टेंस है अब मैंने बोला कि भाई ये तो 20 ओम्स था तो अब मेरे को 20 ओम्स पता चल गया यहाँ पे वही सेम है नाउ द वोल्टेज इज दिस मच सो देन आई कैन से ओके द न्यू पावर इज V स्क्वायर बाय R तो V तो मेरा 10 है 10 times 10 डिवाइडेड बाय 20 तो मेरे को 5 वॉट्स की पावर मिल रही है 5 वॉट्स आंसर हो गया इसका ठीक है ये लॉन्ग मेथड हो गया मैंने रेजिस्टेंस पता किया देन आई यूज दैट रेजिस्टेंस दिस इज शॉर्ट राइट बट देन दिस इज लॉन्ग कंपेयर टू व्हाट आई एम गोइंग टू डू नाउ तो अब शॉर्ट मेथड देख लो, रियली सिंपल, रियली सिंपल. फर्स्ट ऑफ ऑल यू हैव टू आइडेंटिफाई द एलिमेंट्स यू हैव टू यूज हियर. यू हैव टू यूज दीज थ्री एलिमेंट्स, वोल्टेज, रेजिस्टेंस एंड पावर, एंड फाइंड द रिलेशन बिटवीन देम. सो रिलेशन क्या है? पावर इज इक्वल टू वी स्क्वायर बाय आर. Power is V square by R. Now I'm saying resistance is a constant, isn't it? Resistance is constant. So resistance constant है, तो I can say power is proportional to V square. ठीक है? Resistance constant means proportionality ले आओ यहाँ. अब मैंने voltage को क्या किया? Voltage I have made 1/4. So if the voltage becomes 1/4, power becomes 1/16, क्योंकि V square की proportionality है. तो मेरा 80 वॉट से यहां पे पावर हो जाएगी 80/16 विच इज इक्वल टू 5 वॉट्स. ठीक है, क्लियर है? ठीक है. सो just pause the video and see both the methods here. Both the methods are right. I would prefer you do shortcut for competitive exam like NEET and JEE exam, and you do a long method for your CBSE exam. ठीक है. तो इसका रेजिस्टेंस निकालो and use the same resistance value over there. It's almost 1 hour, but I'm going to extend the class by 10 minutes. Please stand. Do not leave. Everybody try this question now. Everybody try this question. I'm just drawing the circuit diagrams. Don't see what I'm doing. Please continue to do what you're doing. And I should be drawing an alternating current here, but not to confuse students, I'm just drawing the regular thing, the direct current. Awesome job. I've already received 11 responses and 10 of them are right. One student has made a mistake that I can see what was the mistake. Yeah. Very easy question. Yes. Okay, let me count. 5, 6. 32 responses so far, and almost all of them are right. Almost all of them. There are a couple of the answers which are wrong, but out of 32, everybody is right. Almost. So maybe 25 plus students are right. Guys, there is a big audience here. You got to reply fast. More answers coming in. Good job. Good job. Awesome job there. Awesome job. Okay. So I think many students have used the shortcut method here. Okay. Long भी कर लेते हैं, short भी कर लेते हैं. We'll do both the methods. Yeah. Answer is 25 watts, by the way. Awesome job, guys. Really awesome. Right? So long method करते हैं. Long method में क्या है? First find the resistance of this using power is equal to V square by R. So resistance is equal to 220 times 220 divided by 100. It's really a lengthy method. So the power resistance is 220 times 220. And then you come to the other side, you say power new is equal to new voltage square divided by the old. इसको काट दो, 0 0 काट दो, बाकी को 22 रहने दो ना. Why do you want to calculate? Because now you can say, okay, ये 5 टाइम गया, ये 5 टाइम गया. So this is 25 watts, right? Now the easy method or the shortcut method is you say, oh, V square by R is the power. All I'm doing is I'm taking the same resistance and plugging into the new configuration. So resistance should not change. Power is proportional to V square. Shortcut method है. You can just do it in a snap. So voltage को क्या हुआ? Voltage becomes 1/2. 1/2 हो गया. तो ये 1/4 हो जाएगा. क्योंकि उसका स्क्वायर हो जाएगा ना, उसका स्क्वायर कर दिया. तो ये this became 1/2. This got to become 1/4. So this becomes 25 watts. Isn't it easy? है easy है. ठीक है. तो एक और क्वेश्चन करो. So we are going to end the class in 5 minutes. 5 more minutes, guys. You're already there. Just 5 more minutes of your time. Awesome. So many answers already coming in. इसमें रेजिस्टेंस चेंज होगा, प्लीज रिमेंबर, इसमें रेजिस्टेंस चेंज होगा, वोल्टेज चेंज नहीं होगा, क्योंकि वी आर कटिंग द रेजिस्टर, changing the resistance, connecting into the same voltage. A proportionality, you have to use the proportionality, but resistance does not change. So resistance changes, voltage does not change. Awesome, so many answers are already right. So let's take the coil this time. ये coil थी, ठीक है, इसको एक वोल्टेज सोर्स में लगा दिया, ठीक है, ये कॉइल थी, इसका सम पावर थी, सम वोल्टेज रेजिस्टेंस था, ठीक है। अब मैंने उस कॉइल को हाफ कर दिया, तो छोटी बना देते हैं यहाँ पे, हाफ बना के, एंड आई हैव कनेक्टेड इनटू सेम काइंड ऑफ वोल्टेज हियर। शॉर्टकट मेथड्स यूज करो प्लीज, शॉर्टकट। सो नाउ रेजिस्टेंस का क्या होगा, रिमेंबर फ्रॉम द प्रीवियस क्लास और प्रीवियस चैप्टर, रो एल बाय ए, राइट, दिस इज रेजिस्टेंस। इसको चॉप कर दिया, आधा कर दिया, लेंथ आधी मीन्स रेजिस्टेंस आधा, क्योंकि एरिया ऑफ क्रॉस सेक्शन इज नॉट चेंजिंग, dense or the resistivity is not changing, so here what you see is resistance is proportional to L. आधी length means आधा resistance, so इधर resistance half हो गया। अब मेरे को न्यू पावर पता करनी है, तो लेट्स राइट द फॉर्मूला, पावर इज इक्वल टू V स्क्वायर बाय R, ठीक है ना, सेम फॉर्मूला, बट वोल्टेज इज नॉट चेंजिंग बिकॉज यू आर प्लगिंग इनटू द सेम सर्किट देयर, सो आई कैन से पावर इज इनवर्सली प्रोपोर्शनल टू रेजिस्टेंस। रेजिस्टेंस हाफ हो गया तो पावर डबल हो गई, ठीक है ना, तो डबल हो गया, that's all you got to do, ठीक है। सो इट्स इनवर्सली प्रोपोर्शनल एंड सो मेनी स्टूडेंट्स ऑलरेडी गिव द राइट आंसर। तो अब देखते हैं नेक्स्ट क्या है, एक और सरप्राइज क्या हो सकता है, सोचो। पहला तो मैंने डिस्काउंट दे दिया कि भाई 2600 का कोर्स है, इट्स कमिंग फॉर 999 टुडे, दैट्स मोर लाइक मॉनेटरी, यू सेव मनी, राइट, बट दिस सरप्राइज इज एक्चुअली अ फील गुड सरप्राइज। लुक एट व्हाट दिस इज। The question that you did, so many students already replied, was a part of JEE Mains exam 2005. You are in grade 10th right now and you have solved a question that came in mains exam. पीछे जाते हैं, this question came in JEE Mains exam 2006. You are in grade 10th and you have solved two questions which were in IIT JEE Mains exam. ये ज्यादा फील गुड वाला, दिस इज अ बिगर सरप्राइज आई वुड रादर से, ठीक है। मैंने कुछ प्रॉप्स रखे थे, आई फॉरगॉट टू शो यू। सो दिस इज कॉल्ड अ फ्यूज वायर, अगर दिख रही है कैम में तो this is called a fuse wire. Now this is one of the things that is based on heating effects of current, and we'll cover this in more detail when we go to the course, 13-hour course, but मैं briefly बता देता हूँ, I'll take another couple of minutes of yours. तो when you have an appliance, let's say, एक बार, और ये बल्ब मैंने दिखाने के लिए रखा था, old fashioned बल्ब, बड़ी मुश्किल से मिला, they don't sell it anymore, बड़ा गंदा सा भी है, तो इसके अंदर एलिमेंट है, दैट एलिमेंट गेट्स हीटेड अप। द न्यू बल्ब्स आर एलईडी बल्ब्स, दे डोंट यूज ऑल दिस, राइट। सो इस फ्यूज वायर का फटाफट से एप्लीकेशन बता देता हूँ क्या होता है। लेट्स से दिस इज अ रेफ्रिजरेटर, right, so in your book you will actually see kind of like boring kind of a theory there, fuse wire ये होती है वो होती है, I'm going to make it like practical application and please see what I'm trying to say. Let's say this is your fridge, refrigerator, and there is a compressor behind that. Compressor is actually the main component of that, right? So if you study thermal engineering, you will see that in few like next year also. So there are two wires that come into this. One is the live wire and one is the neutral wire. सही, ठीक है, ये प्लग कर दिया मैंने, पीछे जो प्लग है उसमें प्लग लगा दिया मैंने। Obviously there is an earth wire also which is equally important. तो 3-pin प्लग में ये लगा दिया। अब देखो प्रॉब्लम क्या होगी, मे बी दिस रेफ्रिजरेटर कैन टेक 5 amperes, लेट्स से टाइनी रेफ्रिजरेटर, इट टेक्स 5 amperes of current. For whatever fault in the circuit, there is some fault maybe, I don't know, for whatever reason, short circuit हो गया, overloading हो गया, what might happen is this circuit is trying to supply it maybe 10 amperes. Now what is going to happen to the fridge is going to, not the fridge but the compressor motor is going to burn, and it's a big deal because when this burns, it's going to cost you thousands of rupees to repair, or maybe you will say, okay, it's not even worth repairing, I'll have to buy a new refrigerator. ठीक है, I'll repeat what I said. So there is a fridge, it is connected to the power supply, and it needs 5 amperes of current. It is happily getting 5 amperes of current for years and years. But suddenly there is a fault in the circuitry in the house, and somehow 10 amperes current comes in. what would happen is it is going to damage the fridge and you have to throw it away also maybe. उसका solution है ये 5 रुपए का. This really costs you 5 rupees. मैंने कल ही buy किया, that's why I know. I have to put it in my microwave. So 5 rupees thing is the solution to save thousands of rupees of refrigerator. कैसे? And you cannot see this because it is built inside of the refrigerator. But what you do is you plug this in. ये लेके सर्किट में लगा दिया. इसके अंदर एक पतली सी वायर है. ठीक है? There is a tiny little wire inside of it. Let's make it blue color maybe. This wire, this blue wire is called the fuse wire. Now this fuse wire is rated. When I go and I said, okay, मेरे को 10 amperes का चाहिए. This one is 10 amperes of fuse. But for this fridge, you will say to the shopkeeper, give me 5 amperes of fuse. What that means is it can tolerate 5 amperes of current. ठीक है? As soon as more current goes through that, heating effect kicks in I square RT. Right? This is the amount of heat generated. Now the more current comes in, I square RT increases, more heat is generated. Iska melting point is so much that it can tolerate heat of up to 5 amperes of current. Anything more than that, it is going to burn. The wire inside of that will melt. It cannot tolerate the heat. तो fuse melt हो जाएगा, ये wire melt हो जाएगी. Circuit is broken now. Circuit is broken, that is a good news because that extra current was not going into the fridge. Fridge will shut down. It will be turned off. Right, which is a good news. Damage nahi hua. And then you can call the electrician. Electrician is going to repair the circuit in your house. And then you can go to the shop, buy 5 rupee thing and just plug it in back. Not you, your parents obviously, right? So that is one of the applications of heating effects of current. So we're going to do all this in the class. So this was one more surprise. So here is the URL. So you might want to register for next 4 hours. There's a deal going on for $9.99. So note down the thing here. Another reason to join. There is a 100% money back guarantee. If you don't like the course in 1 or 2 classes, you can take your money back. But I doubt that you will do that. Because if you take 1 or 2 classes with me here, I have a full confidence based on the past year batches here. Nobody wants to take the money back. You are going to have so much of fun because that's another guarantee I'm giving you. Fun guaranteed. But even if whatever happens, maybe your schedule doesn't match and all that, you can get money back. You join for $9.99. If you don't like it, you can get money back. If Vedantu, you don't want to go through Vedantu, you call me directly and say, sir, please, I want money back. I will deal with the department that gives the money back and I'll give it back. ठीक है, नहीं तो अपनी पॉकेट से दे दूंगा. I can guarantee that. I'll Paytm the money. Paytm करो. I'll do the Paytm to you. ठीक है, गारंटी. मैं अपनी जेब से 999 का 1000 रुपए Paytm कर दूंगा. ठीक है, तो I will see you guys and the free webinars are a part of the Vedantu ongoing campaign to impart free knowledge. So there is no obligation to join just to get free knowledge. You can join the webinars. This is what I'm recommending you. So see you in the classes or another webinar. So this is not a goodbye. It's just to say see you soon. Okay? Discipline is the bridge between your goals and accomplishments. Thank you so much everybody for joining. Have a great day. Bye bye.